Hello and welcome to Module 4, Inserting Data. In this training course, we're going to talk about how to get data into ClickHouse. There's not one way to do it. There's lots of ways to do it. And so we'll focus a lot at the beginning of this module on table functions, which really allow you to just grab data from anywhere. And then the other nice aspect that we'll discuss in this training is input formats and output formats. ClickHouse can read just about any input format that you can imagine. And so between the table functions, the input formats, and another discussion on table engines, you'll see that you have lots of options for getting data into ClickHouse. As you can see, Module 4 is a part of this 12-part learning called ClickHouse Developer. We've got ClickHouse up and running, we've created our tables, and now it's time to insert some data. So let's get started. Let's take a look at how to insert data into ClickHouse. And there's lots of options. There isn't like one magic tool or something. It's a SQL database, so any client that can connect to it can insert using a SQL insert command, insert rows. So there's options, like if you're using ClickHouse Cloud, it's super easy to upload a file or use ClickPipes to connect to Kafka. That's really nice. And we have the client tools, like ClickHouse Client works great, and ClickHouse Local as well. If your data is coming from something like Airbyte or DBT or Vector, one of these ETL type applications, they all have a ClickHouse connector as a sink. And so those are super easy to connect to ClickHouse. If you got data in another database, whatever the method is, if you have to write your own program in Java or Python or something, just lots of options here. No really one way to do it. What's nice is wherever your data sits now, so these sort of have these two questions on the slide here. Where's your data and what format is your data in? Wherever your data sits now, there's probably a table function, and that's what's super nice. And I'll go through a bunch of table functions here in the next few slides. And then I'll show you the input formats, just dozens and dozens, literally of dozens of formats that ClickHouse can just read from. And so that's really nice as well. ClickHouse has these table functions, and I can show them to you in the docs, and then I'll come back to the slides here. If you go over here to the SQL reference, you can see that we have a section called table functions, and they're just listed alphabetically. That, you think about, well, where is my data now? Is my data in Azure Blob Storage? Well, there's a table function for that. Is your data up in Google Cloud Storage? Hadoop, there's a HDFS table function. Just lots of different options. Is it in another database, or using Mongo or MySQL or PostgreSQL or something like that? Like I said, there's probably a table function to read it. By the way, if you're looking at this and thinking, I use Oracle or SQL Server or something, there's always a table function for that. There's the ODBC one and the JDBC one for connecting to, countless databases. So it's pretty easy to move data from another database into ClickHouse. And so I'll just kind of go through some of these. I broke them down into categories. So for example, if your data is up in cloud storage, like AWS, you can see there's a couple of functions, S3 and S3 cluster. The difference being the cluster functions, if you have multiple files to download, it'll take the task of it doesn't download files, it streams them, but it'll take the task of streaming the data from those files and put it on your cluster. And so, if you have, for example, a 4-node cluster, you could download from 4 different files at the same time. GCS table function, you can see there's Azure Blob Storage, and that has a cluster version as well. For what it's worth, if you're looking for GCS cluster, just use S3 cluster. They're basically the same function behind the scenes. These table functions return, it's a table-like interface. You can just, leave the file up in S3 and query the file if you want with just using normal SQL. You can treat the contents of that file as a table, and we'll talk about that. Is your data in another database? Well, same deal. We got those 4 databases, PostgreSQL, MySQL, MongoDB, SQLite. That's great if you're using one of those 4. But like I said before, if you're not, well, just use the ODBC or JDBC table function. Those will obviously connect to just about any database there is. Notice we have, Iceberg. If you're using Iceberg up in S3, there's a table function for that. Same for Hudi, same for Delta Lake, and so on. The table functions work great for grabbing data and pulling it in. If the data is getting sent to you, like Kafka, RabbitMQ, NATS, those require a table engine. You don't sort of ask for the data. You set up the table engine and it subscribes to the topic. And so that's kind of a little bit different, but very similar concept. I'll show you an example of that later on in the slides. But again, if your data is coming from any of these sources, table function, we have it. And they all kind of look alike. There's a lot of similarities in the table functions. So what I want to do is kind of look at just one example and then kind of break it down. I'll actually walk through one of these. You know, you got a table function here. I got a file up in S3. It looks like I have a CSV file. You can see by the file extension, the 1.3, that's going to be 3 files. It's going to be my underscore file 1.csv, and then file 2.csv and file 3.csv. And then I pass in my credentials, and the CSV right here, well, that's the format of the data in the file. And then if you want, you can specify the schema of the data in the file. So this timestamp, level, and message, those are the 3 columns that must be in this CSV file. And it looks like I'm selecting timestamp and message here in this sort of simple example. So that's nice and tedious. I mean, it's nice, but it's also a lot of typing. I had to type in the schema and all this stuff. Well, for what it's worth, ClickHouse will infer the schema. And what it does is it reads like 50,000 rows. I mean, it just reads a ton of data and figures out patterns in the data to decide, is that a date? Is that a float? Is that a string? And it does a really good job. I mean, it's super handy. So instead of typing in a schema, if ClickHouse can figure out the schema, you don't have to include it in your table function. And like I said, this is S3, but it's true for most of the table functions that read from files. And you can even take it one step further. The fact that the file has .csv in the file name, you don't have to put CSV as the data type. ClickHouse can figure out it's a CSV file because you called it that. And I don't even have it on the slide, but if it was .csv.snappy or csv.gz, or even you can flip the 2 around, .gz.csv, it doesn't matter. If ClickHouse can figure out the compression from the file extension, it will. And so you don't have to specify that either. So it does a lot of it for you. Really, if I didn't have to pass in the credentials, I could easily just call this with one line if that file didn't need to, have an access key and so on. So there's all these different table functions. And then let me show you the input formats, and then I'll go through an example. We just have a bunch of data formats, and you can see the, kind of some obvious ones here on the slide, like tab separated, comma separated, JSON, and so on. But, we have a lot of other ones too, all the popular ones like Protobuf and Parquet and Orc and so on. And if I go over here to the docs, if you go to the main page and scroll down to data formats, we have a few picked out here, but I love this page right here. If you click on view all formats, it's a nice table. There's like 80 some, data types in here. And it tells you whether it's an input or an output, or most of them are both, I guess. Tab separated, comma separated, lots of those. There's a bunch of different ways to read in JSON. The pretty ones are all just output formats. You can see Protobuf, Avro, Parquet, Arrow, Orc. It's nice. I mean, this is pretty cool. So between the two, between a whole bunch of table functions and a whole bunch of file formats, it's usually pretty straightforward to read in a file. And so just for example, you got a Parquet file in GCS, use the GCS table function. If the name of the file has .parquet, you don't even have to do anything extra. You can just, this query right here, well, this selects every row, but select whatever you want from the file. You can just grab it using the GCS table function. Very convenient. You got a Delta Lake table in S3, there you go. Just use the Delta Lake table function. You have a orc file in the Hadoop file system. Well, use the HDFS table function. Here I specified orc and specified a schema for whatever reason, just to kind of demonstrate that sometimes you pass in the schema and sometimes you don't. If it's a table in another database, like here I have a PostgreSQL example, well, you pass in kind of the obvious things you would expect to pass in. Where is the server at? What's the host name? What's the name of the database? What's the name of the table? How do I log into that table or that server? That's all the things you would expect in the PostgreSQL table function. Kafka is a little bit different, like I said before. That's not a table function, it's a table engine. This is me subscribing to a topic called my_topic running on this particular host, and the format is JSON each row. And so you have to set that up using a table engine. Check the docs for all the different settings, lots of different settings for that. And I'll show you just super quick in the ClickPipes. When I get to the Cloud UI, I'll show you what ClickPipes looks like. There's table functions, there's table engines. How do I know which one to use? Well, to be honest, the table functions just use the table, the table engines just use the table functions. There's, if you use the S3 table engine, I can show you in the docs where these are. And you'll notice that under the integration section in the table engines, and they're listed alphabetically as well, it's a very similar list. Azure Blob Storage was a table function. Well, there's also a table engine. S3 was a table function. Well, there's also an S3 table engine. What's the difference? Well, the S3 table engine, the table engines in general, store all the connection details, the type of file, the schema, the credentials to log in. You don't have to pass that in every single time. So you create a table with an S3 table engine, for example. The files stay on S3, but you query the files just like it was a table on ClickHouse. Every time you run the query, it's going to stream the contents of the files down into your ClickHouse server. So the table engine is like a proxy. So here in this example, I'm using the S3 table function, and I have to pass in like 5 different things, and it gets pretty tedious and it gets a little wordy. If I just create a table, here I called it my S3 table, with the schemas right here, I can say it's got a message of type string and a timestamp that's a uint64. And then the engine is S3, and there's the URL. There's the credentials, the CSV, the gzip. And now I don't ever have to type any of that stuff in again. I can just select whatever from my S3 table, and behind the scenes, it'll go out and grab that data off of S3. So that's kind of the difference between the table functions and the table engines. One last comment, there is also, for Postgres and MySQL, there are also database engines where you can connect to an entire Postgres database. That makes it super easy to query, hundreds of tables in Postgres. So that's nice. But again, the data is sitting in Postgres. So every time you write the query, it's going to stream that data into ClickHouse. Same with MySQL. You can connect to a bunch of tables in MySQL in a database. Again, it's streaming the data in every single time. Is this fast? I don't know. It's not super fast. It's not ClickHouse fast. Remember all the conversations we've had up until now. When it's time to query the data and take advantage of the absolute full capabilities of ClickHouse, we're going to take that data and put it into a merge tree table engine. So yeah, I might have a PostgreSQL table engine, but it might just be temporary, or I might just query it once in a while, or I might just use it at the beginning to move data between the two systems. So let me show you some examples. And I'll just start with a table function since we talked about it. I have over here in S3, these are Parquet files. The files themselves are compressed with a snappy compression. I don't know what the Parquet file inside the file is compressed as, but I just copied the URL. This is a public file, so I don't have to, log in or anything. I don't need credentials to access this file. Oh, that URL looks pretty big here. Let me try that again. Let me click on the file. Here we go. This is the link I want. Copy link address, paste. It's a table function, so you can treat it like a table. One thing you can do is you can use the describe command. You can describe the table. This is the inference that I was telling you. I didn't pass in Parquet. I didn't say it was a Parquet file. Now I could. I can go up here. If I have to, I can say Parquet. And if I have to, I can put another comma and I can specify the columns. But I don't, especially with Parquet, I don't have to do that because Parquet is one of those nice file formats where the schema is embedded inside the file. So you can see this has, 15 columns. And these are reviews. These are old reviews off of Amazon. So what I'm going to do is I'm going to copy that part of it. And we can just grab some rows. I'll just select star from, and yeah, you can almost treat it like a table. I don't want to put Parquet there because I don't have to, and I can't grab everything. I don't know how many rows are in this table, but I'll just grab 1,000 rows. So we can get a sense of what the contents of this file looks like. Now what is happening right now is ClickHouse is going out and grabbing a chunk of rows from this Parquet file and streaming it into my cloud instance. That took a very long time. That took almost 9 seconds, which was completely, nothing exciting at all. It coincidentally processed a granule's worth of rows. And you can see that that's the date it happened as an integer value. There's a customer who wrote the ID. And if you scroll over here, you can see the product of whatever it is they were reviewing. And then if you go way to the right, there's ratings, like they gave it 5 stars. There's a headline. Every review has a headline and then the actual review. A real pleasure. Okay, so someone liked that album. All right, let's do this. Just one more thing. This one goes pretty quick with Parquet, I think. Let me see how big this file is. And again, I could have left the Parquet there. I just don't want to have it on there. That is, well, let's do my favorite thing, format readable quantity. I think it's 41 million rows. It looks like it's 41 million rows, but we'll just verify it. Almost 42 million rows. All right, let me show you a little trick here. I'm gonna go back up to that describe statement. Let's create a table for this. I like that I can, it's got all the column names. I feel like the table description is just right there, ready to be grabbed. I'm not a fan of nullable. We talked about nullable in one of the earlier modules, module 2, I believe. And I don't want every single column to be nullable. There's this setting in the, you can find in the docs. It's schema, inference, and then I think it's make columns nullable right there. I want that one. I'm going to take this setting right here, and you'll notice it's, what's the default? It's true by default. Yeah, it says it's enabled by default. So if I turn this off, you'll see the difference right away. If I set that equal to false and I do a describe, it doesn't put nullable around all my columns. I'm just going to copy and paste all this. I'm going to try and be as lazy as I can to create this table. I am going to create a table, and I'll just call it reviews. And doing there. Let's do a paste. And then I'm going to clean up the data types. I'm okay with the data types. They're probably fine, but I know right off the bat that the review date is not an unsigned integer. I mean, it is, but it's also a date. So I'm going to make that a date. Marketplace is definitely low cardinality, so I'll make that a low cardinality string. I got to put commas in here too, by the way. The customer ID is fine. The review ID, the product ID, these are all fine. I just got to commas after them. I'm sure these are fine. Some of these could probably be low cardinality. I think the product category could definitely be low cardinality. And these ratings are like 0 to 5, so they're super small. And ClickHouse was smart enough to know that, like they only picked UN8 forms. I'm okay with the Booleans. And these are definitely not low cardinality. Every review is going to be, I would assume they'd all be unique. Let's set the engine equal to merge tree. Let's set the primary key to, I think I'll do review date, and the product category is pretty nice to filter by, and that's not too high a cardinality, so that's a good, that works out pretty good. So there's my table. All right, let's see how I did. Hey, it worked. That was exciting. And then I'm going to insert into reviews. And I'm going to select star from, and I'm going to just grab the S3 table function here. And it's 42 million rows. Let's see what happens. I mean, I would assume this will take a while. I don't have a production instance on ClickHouse. I'm using on ClickHouse Cloud. I'm using the development instance. So I have 16 gigabytes of RAM, which is, plenty of RAM, but I wouldn't expect this to, it's still 42 million rows. I would expect this to take a while. And it's one file, so I can't really use S3 cluster with much benefit. Let's see where we're at here. Let me do select count from reviews. Let's format it again. And see how many we have. Oops, did I spell it wrong? Nope. We're up to 7.6 million. Oh, so we got a ways to go. So let's wait. I'll just pause for a second. Well, we'll let that run in the background, because what I can do over here is sort of, while that's ingesting, let me just go through a few things. One really common thing, I mentioned ClickHouse Client and ClickHouse Local, really common to use these. Remember, you can connect to ClickHouse Client from ClickHouse Cloud. This is localhost in this example, but if you're in the cloud, just go over here and grab your connection string and just copy and paste it. You have to add your password to the end of it, but that little connection string right there is exactly what you need to connect to it. And then you can specify a query. Whatever you cat, see I'm catting this CSV file, you just have to insert it into whatever table you want. And here I specified the format was CSV, but I bet I didn't have to do that because the inference would have figured that out. In ClickHouse Cloud, we have something called ClickPipes, and ClickPipes is for Kafka. Here, I can show you that, I think, without ruining my insert's still going. Let's see where we're at just for fun. I'm up to 17 million. We're making progress. Let me click on imports. And then you can see there's set up a ClickPipe. Now today, of whatever the date is today, it's early 2024. We allow you to select a data source these are Kafka related type events. Now I can see we have some new ones here: Azure Event Hub, WarpStream, and Upstash. Whatever it is, let's say you're using Confluent Cloud, the UI just walks you through it, and you enter all the things you would expect to enter: the API key, the topic you want to subscribe to, and then when you type all that in, it'll actually grab a couple of rows. It'll figure out a schema, and it'll figure out you get to enter the table name, and it's a wizard that walks you through the whole process. So ClickPipes is great if you're using Kafka and you need to grab data from a topic. The other thing you can do is upload a file. You can either grab a file off your laptop or computer, or you can just type in a URL, which is super nice. Like if I go over here, now it doesn't work with Parquet files, but if I pick a different file, what do I got? Here's a CSV file called Apple Stock. That sounds like Apple stock prices. And you paste the URL into there, and it just kind of takes over from there. Notice it grabbed a few rows. These definitely look like stock prices. There's the date, the open, the high, the low, the volume, the close, and everything like that. And you can go down here. I can say, hey, create a new table called Apple Stock. Notice I can pick the primary key, which would probably be the date in this case, or I suppose I could add a couple columns. And then that's it. You can just click the button at the bottom of the page. It starts it as like a task, but that's just a CSV file. I'm not surprised that that happened very quickly. If I go over here and refresh my table list, I can see that Apple Stock is right there. So that was a super quick way to grab a file off of S3 and insert it into ClickHouse Cloud. And just for fun, let's see where we're at. Hey, we're getting close. We're at 35 million rows. So that, what I just showed you, I have it on the slide here. So there's ClickPipes for Kafka and a few other sources. And then there's the way to grab a file off of, like I said, off your file system or off the cloud somewhere, off a URL. For what it's worth, if you have data already in ClickHouse, whether you're moving it from one ClickHouse instance to another, or whether you're going from a self-managed ClickHouse up into ClickHouse Cloud, any direction, doesn't matter. We have a great function called Remote Secure. And if you go to the docs and you go to our cloud page, we have a section on moving data around. And right here, migrating to cloud. And it's on the ClickHouse local page. Nice examples that show you how to use the remote secure function. So anyway, you can walk through that if you need to. Yeah, it's nice. I mentioned the tools already. I didn't necessarily mean to pick on these three and sort of elevate them. But Airbyte, DBT, and Vector, what I like about them is that if you do go to our documentation page, we have nice pages here on how to use them. So if you go to the integrations, you can see there's the DBT page and the Vector page. It's a little bit hidden, but it's down here. Yeah, great. They work really well with ClickHouse. So that's why I singled out those three, but I don't care what use your favorite ETL type tool. Those work great. Same with writing your own code. Obviously, we have a lot of users that have to write their own code because that's just a big part of working with databases is writing the client. JavaScript, Java, Go, Python. Again, I didn't necessarily mean to single out 4 languages like that. The only reason I put those 4 on a slide is because if you go to the docs and you go to view all languages, we actually maintain these in GitHub. So the JavaScript client, Java, Go, and Python, we as a company, ClickHouse, maintain those in their open source. If you're using something else, another language, use another language. If you're using .NET, go out and find the ClickHouse.NET client. It's great. It's out there in the community, and we highly recommend it, and we tell everyone to go use it. Writing code in Rust, go out and find the Rust connector. I mean, there's a connector for all these, all the community clients for all the other languages out there. So, all right. Oh, there's a lab, but before you go off and do the lab, we should finish playing around here. This might be done, by the way. Yeah, I'm up to 41.9. If I go back here, you can see that it returned. And so now I took that file. Now, I only did one file, but I should point this out. If I had wanted to, I could have taken 2015 and put a wildcard there. That's a lot of rows. I don't want that many. I don't want to wait that long for that many rows to be, inserted. But I have this query that I took off of the knowledge base in our docs, and it shows you how much disk space. So I'm reading from system.parts. I'm grabbing all the active parts for the reviews table. And I'm grabbing the compressed bytes and the uncompressed bytes and figuring out the ratio. So this file, uncompressed, was 13.5 gigabytes. I put it into my table on ClickHouse, and it's only consuming 5.72 gigabytes. By the way, the data was compressed with Snappy and whatever the Parquet file was compressed at. ClickHouse compressed that 2.36 times more. You can see the 41.9 million rows, and it currently has 9 parts. So that was a fun little query. And now I can query the data. Like if you just want to see what it looks like. I guess we kind of already saw it, but this goes pretty quick here. I'll just grab 100 rows again. And you can see how fast that is. I mean, it doesn't take long to grab 100 rows. Here's a review for some prosciutto, and you will not be disappointed. Okay, so let's try and find something interesting. How about the most, how about the products with the most views? So if I selected, well, it's kind of confusing because I don't want to group by product title. There's a column called product ID. Let me just grab any product title and then just do a count because I want to see which one has the most from reviews. And I'm going to group by product ID, which should be pretty quick. That's just an integer. We'll just grab the top 20 or something like that. Oh, but I got to order it. Let me order it by count, which is the second one, descending, and that should be the top ones first. It's got to read all 41 million rows, or 42 million rows almost, and I should have had a production instance to make this more interesting. I realized that took 10 seconds. This runs in less than a second if I run it on a production instance with more memory. I only have 16 gigs of RAM, and you know, that's spread across 2 nodes with 8 gig each. So I really only have 8 gigs of RAM on each pod that I have behind the scenes. So you can see that whatever Bosch season 1 has the most reviews in this data set. The Girl on the Train. Let's see let me just do one, just out of curiosity. I want to select the minimum. What was the date column called? Review date. Minimum review date and the maximum review date. Reviews, and we'll see what we got. That was super quick. This is more realistic, by the way, but for what it's worth, review date was the first column in the primary key. It took 2 milliseconds to figure out that these go from January 1st of 2015 to August 31st of 2015. So what, the first 8 months of August or 8 months of 2015, sorry, that's where their reviews come from. So there you go. It's really interesting. It's nice. Look how easy that was. I mean, it was a little bit of work. It's always work to create a table, but I very cleverly used the describe command, saved myself a lot of typing, cleaned up the data types a little bit from the inference. It was close, but it's never perfect. It's never exactly what you want. And of course I had to pick a primary key. All right. In the lab, you're going to see how easy it is to ingest a file in ClickHouse Cloud. You're going to do just what I did. And then in the second lab, you're going to put in that UK property prices data set. I didn't mention it in this module, but we've seen it in the previous modules. You're going to use this data set throughout the labs and the rest of this learning path. So if you keep going and you want to learn about all the other aspects of ClickHouse, you want to learn about materialized views and projections and joins and all that, you're going to want this data set. And in the third lab, I found this CSV file, and I either put some weird things in it or it had some weird things in it. I can't remember. But anyway, I'm going to show you how to deal with a file where not everything is perfect. And I really think that this lab is worth your time. You're going to learn some great, useful tips. So off you go, like I say at the end of all these modules. If you have any questions, you can reach out to us, learn@clickhouse.com. The quickest way to get to us is on the community Slack, clickhouse.com/Slack. Look for the ClickHouse Academy channel. All right, good luck.